Examples on harmonic function and examples on using Milne Thompson method. The first is, if u is given to be 1 upon 2 log of x square plus y square, then find harmonic conjugate of u, that is v, such that f of z is equal to u plus iv is analytic. So we have discussed about Milne Thompson method. It is about finding f of z, the function f of z, and the harmonic conjugate of the given function, so that if real part is given, then we can find its harmonic conjugate, that is v, and if v is given, then we can find its conjugate as a u, and with the help of these two we can find the analytic function f of z of the form u plus iv. So here let us use the given thing u. So let we follow the steps given by Milne Thompson, that let u is a function of xy, that is half of log of x square plus y square. So we can find its derivative. So therefore partial derivative of u with respect to x will be half into derivative of this with respect to x is will get cancelled, and derivative of u with respect to y is again these two will get cancelled, so that is x upon x square plus y square and y upon x square plus y square are the two derivatives of u with respect to x and y. So with the help of these two we have to find the harmonic conjugate of u and hence the function. So let f of z will be of the form u plus iv. So differentiate, therefore f dash of z with respect to x will be partial derivative of u with respect to x plus I times partial derivative of v with respect to y, or we can differentiate with respect to y also. So here, I times then partial derivative of v with respect to x, or we can differentiate with respect to y also. So now if we look at the given things, we have only u, partial derivative of u with respect to x, and partial derivative of v with respect to y. We don't have this term partial derivative of v with respect to x. But since we are finding the analytic function, and by analytic function it satisfies the CR equation, so we can use the CR equations. Therefore by CR Cauchy-Riemann equations, what I can write, partial derivative of u with respect to x is partial derivative of v with respect to y, and partial derivative of v with respect to x is minus times partial derivative of u with respect to y. So here I can write partial derivative of v with respect to x as a minus partial derivative of u with respect to y. Therefore f dash of z becomes partial derivative of u with respect to x minus I times partial derivative of u with respect to y. So let us substitute these two values of the derivatives we are having. So therefore f dash of z will be equals to this is x upon x square plus y square plus I times this is y upon x square plus y square. So here we have f dash of z in terms of x and y only. So we put x is equal to z and y equal to 0 into this. We get f dash of z to be x is equal to z, that is z upon z square plus 0 because y is 0, plus I times 0 upon anything is 0. So therefore f dash of z will be 1 upon z, because z upon z square is 1 upon z. So therefore to get f of z in terms of z, we integrate it. So integrating, we get integrating with respect to z, we get f of z, and integration of 1 upon z is minus 1 by z square. Integration is log log of z. You can say plus constant of integration. So therefore this is the required function f of z in terms of z, which is analytic. And now to find the harmonic conjugate of u, that is v, we substitute z equal to x plus iy according to the Milne Thompson theorem. So therefore put z equal to x plus iy. So therefore f of z will be log of x plus iy. So by separating the real and imaginary parts of this complex number, as we know, for log z, that is, if we write this z in the form of polar coordinate or exponential form, then that will be log of r e raised to I theta. So this, using the log property, I can write log of r plus log of e to the power I theta, that is log r plus I theta. So this is of the form u plus I times v. So log r will be u and theta will be v. So using this is a separation of real and imaginary parts of logarithm of a complex number. So therefore here f of z will be equals to suppose z is equal to x plus iy, then log of z actually we are having, so that is log of r plus I theta, using this. So that is, what is r? R is the modulus of this z, that is log of x square plus y square, and what is theta? Theta is I times tan inverse of y by x. R is actually, this R is actually mod of z, and which is square root of x square plus y square. So this is square root of x square plus y square. So using log property, this square root means raised to half, and that we can write here half into log of x square plus y square, which is given u, and this is v. So therefore what is harmonic conjugate of v? What is harmonic conjugate of u? That is v, and that is tan inverse of y by x. Thank you.